In this video I'm going to answer question number 12. So the question states there are 10 people seated at a rectangular dinner table. So I'm going to line up 10 positions. 1, 2, 3, 4, 5, 6. Tanya is going to sit at the head of the table, so we'll make this the head of the table. So Tanya has to sit here. Now we know that we're told Henry must not sit beside either Wilson or Nancy, which is fine. So we'll have to put that in as a restriction. And how many ways can this be done? So first thing you notice is that since Tanya is here, there's now only 9 positions. So we have 9 factorial. These 9 people can be arranged in 9 ways if there wasn't this restriction here on Henry not being able to sit beside Wilson and Nancy. So we'll call this the no restriction case. Although there is that one restriction on Tanya. So, but ignoring this part about Henry not being able to sit beside Wilson and Nancy, we would have 9 factorial. Okay. Now we want to consider the case, or this is an example of a case where it's easier to count sort of, instead of saying how many ways could he not sit beside Wilson and Nancy, how many ways could he sit beside Wilson and Nancy? So meaning Henry, Wilson, and Nancy are going to have to be together. Or Henry is going to have to be beside Wilson or Nancy. So we're actually going to do that one at a time. So Henry with Wilson. So how many ways could Henry sit beside Wilson? So if you remember how to do that one, Henry and Wilson are going to be treated as one unit. So now instead of 9 positions, we only have 8 because these two have to go together. So we're down to 8 factorial, but Henry and Wilson could sit beside in this order, or it could be Wilson and Henry. So we're going to have to multiply 8 factorial times 2, the 2 being where they switch positions. Okay, so that would be another case, but Henry also isn't allowed to be beside Nancy. So that's just going to be the exact same thing, right? Now we're grouping Henry and Nancy as one, so 8 factorial times 2. So what you're going to have is the total (9 factorial) subtract both these cases. I could just put them in a bracket. 8 factorial times 2 plus 8 factorial times 2. I can't remember what this number is, but if you check the back of the book, this is the answer it gives. That's actually a mistake. They've forgotten one case, and that would be this case that I drew right here. Right? These two cases here, we eliminated the possibility that Henry was with Wilson or that Henry was with Nancy. But there's a possibility that Henry is with both of them. So this case where Henry is or actually this wouldn't be the case. It would be Henry between Wilson and Nancy. Like that. We've counted these in both these restrictions, or both these examples. So we've double counted them. We've subtracted them here and we've subtracted them here. So we need to add these back in. So we subtracted these two, but then we need to add back in Henry between both, or beside both. Okay. And if we want to figure out how many ways he's beside both of them, now we're going to group the 3 of them together. So instead of having 9 objects, we're going to group 3 as 1, so we're down to 7 objects. And then we still have to do 2 factorial because it could be Wilson, Henry, Nancy, or it could be Nancy, Henry, Wilson. So they could just flip. Okay, so we need to add back in 7 factorial times 2. And whatever number that is, I'm not going to do it on a calculator. Whatever that one gives you, that's the correct answer to this question.